Hi, welcome to In 5 Minutes. Next is again a design problem. The main objective in this design is we need to design a MOSFET circuit biased with both positive and negative voltages. What you can see in the diagram, you have positive as well as negative voltages connected to the circuit, right? And what they have told you, the circuit configuration to be designed is shown in the figure. Design the circuit such that IDQ is 0.5 milliampere and VDSQ is 4 volts, right? Again, this type of MOSFET given over here is N MOSFET. So we can use straightforward the equations what we know. So while starting with the analysis, we can see the biasing is not the feedback biasing, right? So what we can say in the solution, we can use the straightforward our equation in the saturation region. So what we write, assuming the transistor to be biased in saturation region. So based on this, what we can use, IDQ, we know the formula. IDQ is Kn VGS minus VTN the whole square, but we don't know Kn. They have given us Kn dash and W by L. So we can find Kn as Kn dash into W by L. This is the formula to find Kn dash by 2 into W by L is the formula to find Kn. So after substituting, you will get it as 0.25 milliampere per volt square. So once you know Kn, we can substitute the value of Kn what we have got here in this equation. And what we need to find in this, ID is given in the question, VTN is given in the question, Kn we have found, so we can find VGS. So substituting the values in the above equation, you should get VGS as 2.614 volts. Now coming to the diagram, the current flowing into this is 0. So what we can say, VGS, how we are writing, VGS is VG minus VS. Since the voltage at the gate will be 0, we can say VGS is minus VS, or we can say VS is minus of VGS. So we can write voltage at the source as minus 2.614 volts. We have got the value of VS. Now when you apply KVL in this loop, so what will be the equation for KVL? We are living with positive signs, so VS. We are living with negative signs, so minus ID into RS, and minus V minus equals to 0. So from this we can find RS as VS minus V minus upon ID. So VS we have got it as minus 2.614 and V minus is minus 5 divided by ID, which is 0.5 milliampere. So this will give you the value of RS as 4.77 kilo ohms. So we have found the value of RS. In order to find the value of RD, we should know the value of VD. So for this, when I apply KVL over here, but before that I need to find VD. I can write VDS as VD minus VS. This is one way to find. So from this I can find VD as VDS plus VS. VDS is given in the question and VS we have already found. So adding these two values, you can find VD as 1.386 volts. Now when you apply KVL, I am drawing the diagram. Again you can say here you have VDD, here you have RD, and here you have VD. Current flowing through RD is ID. So when you apply KVL, equation will be VDD minus ID RD minus VD equals to 0. So from this I can write RD as V plus minus VD upon IDQ. So this will give me the value of RD. So I am getting RD as 7.23 kilo ohms. After substituting the values, I am getting RD as 7.23. Now what is the value of VDS? VDS is given as 4 volts in the question. VDS is given as 4 volts. Now it should be greater than VDS sat. Then only these equations, whatever we have done is right. So we can find VDS sat as VGS minus VTN. VGS we have found it as 2.61 and VTN is given as 1.2. So it is 1.41 volts. What you can say, the value of VDS is greater than VDS sat. That means what we have done is the right, and the standard values for RS is 4.7 kilo ohms, and for RD, since it is mentioned that you find the standard values, it will be 7.5 kilo ohms. So you always take the nearest standard value. So in this case we are taking the highest standard value, which is 7.5 kilo ohms. This is how we have designed the circuit for N channel MOSFET. Thank you for watching In 5 Minutes.